After World War II ended in 1945, tensions between the United States and the Communist Soviet Union were rising. The world's two greatest powers had started what is now known as the Cold War. The Cold War was primarily fought through economic and political actions. Beginning in the late 1950s, space became another frontier for their competition. Each side attempted to demonstrate their superiority through technology and military power. This conflict resulted in numerous missions to be the first country to explore space. This would later be referred to as the space race. May 25, 1961. 20 days after Alan Shepard became the first American in space, John F. Kennedy announced the lofty and difficult goal of safely putting a man on the moon by the end of the decade. This was because of the large amount of pressure placed on John F. Kennedy by the botched Bay of Pigs invasion and the recent technological victories by the Soviet Union. February 20th, 1962. Astronaut John Glenn, one of NASA's first astronauts, became the first American to orbit the Earth when he piloted the Friendship 7 spacecraft for 3 orbits around the Earth. June 3rd, 1965. During the Gemini 4 mission, Ed White became the first American to walk in space. Ed White, along with James McDivitt, orbited the Earth 66 times in just 4 days, making it the first U.S. flight to approach the 5-day flight of the Soviet Vostok 5. June 2nd, 1966. Surveyor 1 became the first American unmanned spacecraft to land on the moon, 4 months after Luna 9, a Russian spacecraft, landed on the moon. June 3rd, 1965. Astronauts Gus Grissom, Ed White, and Roger Chaffee were killed by a fire during a test of the Apollo 1 command module on the launch pad. The fire started when an electrical surge caused a spark that ignited the cockpit because the internal atmosphere of the command module was 100% oxygen. Tragically, they had tried to escape the command module but were unable to, because it would have taken a minimum of 90 seconds for the hatch to open. Following this, major changes like a 34% oxygen atmosphere and an easier-to-open hatch were implemented and were instrumental in the success of all future NASA missions. July 20th, 1969. John F. Kennedy's goal to land a man safely on the moon had been reached when NASA landed Commander Neil Armstrong and module pilot Michael Collins on the moon during the Apollo 11 mission. Approximately 530 million people around the world watched as the American flag was planted on the lunar surface. This marked a major victory for America in the space race. July 26, 1971. Following the success of the Apollo 11 mission, Apollo 15 was the first of what were called J missions. These missions involved extended stays on the moon and had a larger focus on science than previous moon landings. This mission was also the first time a lunar roving vehicle was used. July 17, 1975. The end of the space race was marked when an Apollo module docked with a Soviet Soyuz capsule. This was the first time 2 countries met in space. The 2 capsules were a part of the Apollo-Soyuz test project and had launched approximately 7 hours apart from each other. April 12, 1981. Columbia became the first space shuttle to be launched. This marked the beginning of an era that allowed space travel at a fraction of the cost. The Columbia's boosters were recovered and reused, while it used its wings to safely coast to the ground, saving millions of dollars. April 4th, 1983. The second space shuttle, Challenger, was launched. That mission saw the first spacewalk of the reusable space shuttle program. While it was in service, the Challenger flew the first African American and American woman into space. It also carried 3 Spacelab missions and was the first shuttle to launch and land at night. January 28, 1986. The Challenger's 10th mission, STS-51L, launched. The mission commander was Francis R. Scobie. He trained as an engine mechanic in the U.S. Air Force while taking night classes to become an aerospace engineer at the University of Arizona. He became an Air Force pilot and began testing new aircraft. He flew over 6,500 hours in more than 45 different aircraft. In 1978, he began working for NASA. The pilot of the mission was Michael J. Smith. He went to the U.S. Naval Academy, where he earned his master's degree in aeronautical engineering. After this, he worked for the Navy's Advanced Jet Training Command and became a test pilot for the Navy. Smith was selected as an astronaut by NASA in 1980 and STS-51L was his first flight. The three mission specialists were Judith A. Resnick, Ronald E. McNair, and Ellison S. Onizuka. Resnick received a Ph.D. in electrical engineering at the University of Maryland. She was selected as a NASA astronaut and worked in multiple fields of the shuttle program. McNair received a doctorate in physics from MIT. While working at NASA, McNair was the second African American in space. STS-51L was his second shuttle mission. Onizuka earned his bachelor's and master's degree in engineering from the University of Colorado. He served in the Air Force before being selected by NASA for the space program. He was chosen for his first mission since he was an Air Force officer on duty with NASA. STS-51L was his second mission. The other two of the 7 astronauts on the mission were civilians. Gregory B. Jarvis served as a payload specialist on the mission. Jarvis was supposed to gather information about the design of the liquid-fueled rockets while on his first ever shuttle flight. The Challenger mission had such a large impact in viewing by the nation because of the last crew member, Sharon Christina McAuliffe, a New Hampshire teacher. She was selected out of more than 11,000 applicants and trained for over a year to become the first teacher in space. NASA's 25th shuttle mission, STS-51L, had many design flaws. First of all, engineers at NASA knew the O-rings had not been fully tested in extremely cold temperatures. The purpose of rubber O-rings was to seal the fuel segments that prevented hot combustion gases from escaping into the engine motor. However, the O-rings were not tested under extreme weather, in which the space shuttle was launched on that morning. The previous coldest launch was 20 degrees warmer. This caused the O-rings to stiffen and failed to fully seal the fuel joint. As the space shuttle ascended into the sky, the gap between the eroded seals widened as the altitude increased. This allowed a plume of exhaust to leak out into the external tank, causing it to explode. The shuttle exploded at 73 seconds after launch, where it tore to pieces. The crew compartment ascended 12.3 miles before it came down crashing into the Atlantic Ocean. The launch of the space shuttle was originally supposed to be on the 22nd of January. However, it was delayed due to a weather front that would bring rain and cold temperatures. The supposedly second launch was also delayed after a defective microswitch in the hatch was reported. NASA managers hesitated to launch the shuttle because of economic considerations, political pressure, and scheduled backlogs. However, unforeseen competition with the European Space Agency pressured NASA to fly the shuttle in order to prove the space transportation system cost, effectiveness, and political commercialization. While people were looking into the past, examining the reasons why the Challenger might have exploded, some were peering into the future in order to prevent a tragedy of this caliber from striking again. NASA was taking a new, more conservative route into the future, making sure everything is right before making the launch. In order to fund these new safety regulations, NASA's safety budget increased by 72% in order to fund the installation of these safety measures. Management was flushed out and replaced by a new wave of regulators. Inside the spacecraft, there were newly installed countermeasures to avoid such a devastating explosion, alongside with an on-site medical branch to be there if things went down an unexpected turn. Even the launches themselves were run several times in an enclosed environment or virtually in order to ensure the correct standards were being upheld. Without the safety standards introduced by the explosion of the Challenger, many more lives could have been lost.